Assalamualaikum and good day everyone. Before we proceed with today's lecture, I would like to highlight what we learned last week. A relationship is a link between the entities. A diamond shape represents it. The label for the relationship is a verb or conjunction and it links the two entities by a line. For example, lecturer is connected with course through the relationship teachers as shown on the slide. In terms of the degree of the relationship, there are three types: unary, binary, and ternary. A unary relationship is also called a recursive relationship and involves only one entity. The binary relationship is between two entities, and the ternary relationship is a simultaneous relationship between three entities. Please bear in mind that not only entities can have attributes, but relationships can also have attributes as shown on the slide. But if the relationship has too many attributes, we must change the relationship into an entity. Relationship cardinality describes the number of relationships between one entity and other entities. Three types of relationship cardinality exist: one-to-one, one-to-many, and many-to-many. Entity participation can be classified as compulsory or optional. Participation is compulsory if the minimum cardinality is 1. If the minimum cardinality is 0, participation is optional. The symbol for optional participation is a small circle by the entity's side. Besides the relationship, I have also touched on the guidelines for constructing the entity relationship model. Please take note, do not insert the sister environment in your ERD. For example, you cannot include a restaurant, hospital, or library as they are examples of environment. By now, you should know how to identify your entities, attributes, and the relationship between these entities from a given scenario. Don't forget to apply the top-down approach. Today, we will continue our lecture for week 6 on topic 5, Enhanced Entity Relationship Model. 4 subtopics will be covered. We will see what is meant by weak entity, composite entity, superclass, and subclass entity. The last part of the lecture will cover the characteristics of relational DBMS. Most entities in an organization exist independently, which means they do not depend on the existence of other entities. These entities are called strong entities. So, what is meant by a weak entity? The weak entity has opposite characteristics to a strong entity. The existence of a weak entity depends on the presence of other entities. Please bear in mind that a weak entity does not have its key. The symbol for a weak entity is a rectangle with two sides. An example of a weak entity is dependent, which depends on the existence of the worker entity. Can you think of another weak entity? The many-to-many relationship in an ER diagram shows a complex relationship and can be simplified by transforming the relationship into an entity known as a composite entity. The diagram on the slide shows the many-to-many relationship between doctor and patient. The treat relationship is made into a composite entity as shown on the slide. The many-to-many relationship is broken into two: the one-to-many relationship between doctor and treatment, and the many-to-one relationship between treatment and patient. A diamond symbol inside a rectangle represents the composite entity. Observe the arrangement of one-to-many and many-to-one between doctor, treatment, and patient. The M relationship is placed at the composite entity, not the original entity. So, how do you read this new relationship? A doctor can give many treatments, and each treatment is provided by one doctor. Many treatments are received by a patient, and a patient gets many treatments. I hope you understand the difference between the weak, strong, and composite entities. Now, let's move on to the superclass and subclass entity. The concept of superclass and subclass was introduced to represent the type of entity with the same characteristics and, at the same time, some different characteristics that are important to the organization. For example, the student entity in a university has two categories, that is, diploma student and degree student. In this case, student is a superclass with two subclasses below it. A superclass shares the same attributes, whereas a subclass has different attributes from other subclasses. Let's look at the example on the slide. There are three different types of workers: contract, permanent, and consultant. What are the similarities between all three types of workers? Yes, they have a few attributes which are the same, namely worker number, worker name, address, and date begin. So, these attributes will be put in the superclass, and the remaining attributes will be set in the subclass as shown on the slide. Please note that each subclass attributes belong to its subclass. For example, contract staff has its specific attribute, that is hour rate. Permanent staff has its particular attributes, which are basic salary and allowance, and the negotiator has its distinct attributes, pay rate and contract number. Now, let's have a look at this example. There are three different vehicles: car, lorry, and motorcycle. Each of these vehicles has its attributes. Can you list out the similar attributes that all vehicles have? I am sure you are aware of these similar attributes as highlighted on the slides. Now, let us draw the superclass and subclass for the diagram in the previous slide. All the similar attributes are placed at the top of the superclass. We can name it a vehicle representing a car, lorry, or motorcycle. The specific attribute that belongs to that particular subclass is drawn below as shown on the slide. Do you realize there is no motorcycle at the subclass level? Do you know why? Yes, it is because a motorcycle has all the attributes already at the superclass level and doesn't have a unique attribute that belongs to it. In the previous slides, I have shown how generalization is applied. Now, let's take a look at the specialization concept. For example, let's say we have an entity named furniture with the attributes shown on the slide. From the furniture, we can specialize them into made furniture and purchased furniture as shown on the slide. As you can see, the subclass made furniture has one unique attribute and the subclass purchased furniture has two special attributes. Now, I will explain the two constraints in the superclass and subclass relationship. One is the disjoint rule and the other is the overlap rule. We are going to see the example for disjointment first. Vehicle can consist of a car or lorry, but not a combination of the car and lorry unless someone invents a combination of both vehicles in the future. Therefore, the small letter D symbol is placed in a circle linking the vehicle subclass as shown on the slide. The overlap rule is the opposite of the disjoint rule. The overlap symbol is an O placed in a circle as shown on the slide. In this example, we can categorize furniture as made and purchased furniture. The following slide shows a more complex superclass-subclass relationship example, where we combine disjoint and overlap rules. So, can you differentiate between them? I am sure you can understand the diagram based on what has been taught to you. Please note that a subclass can have more than one superclass as shown on the slide. It is called unification and is represented as a U symbol. For example, we can say that the asset owner contains individual and organization superclasses. Now, let's move on to the characteristics of a relational database management system, also known as RDBMS. Just remember this word, ACID, acid. A is for atomicity, C is for consistency, I is for isolation, and D is for durability. Atomicity means that multiple operations can be grouped into a single logical entity. Other threads of control accessing the database will see all or none of the changes. There are no partial changes. I do hope the diagram on the slide reflects my explanation. If you don't get it, you may ask me during our next lecture. Now let's move on to the consistency. Consistency in database system refers to the requirement that any given database transaction must change affected data only in allowed ways. To be consistent, data returned to the database must be valid according to all defined rules, including constraints, cascades, triggers, or any combination. Isolation is typically defined at the database level as a property that determines how and when the changes made by one operation become visible to others. As for durability, it ensures that changes made to the database that are successfully committed will survive permanently even in the case of system failures. It ensures that service outages, crashes, or other failure cases will not corrupt the data within the database. I think that's all for our class today. Please WhatsApp me personally if you have watched the video. Thank you all, and I am looking forward to meeting all of you in our next class. Have a nice day, everyone.